This podcast explores the key metabolic changes associated with a ketogenic diet, as well as the importance of maintenance of plasma glucose while on that diet. Why we need glucose? The simple answer to that question is because we have a brain. The brain's favorite energy source is glucose. Although the brain can use ketone bodies, it cannot use fatty acids because of the blood-brain barrier. In addition, the brain will access ketone bodies only when they reach quite high concentrations in the bloodstream. In fact, when glucose in the plasma drops, the brain sends instructions through the hypothalamus and the autonomic nervous system to the pancreas and adrenal glands, releasing glucagon, epinephrine, and cortisol, and instructing the liver to restore plasma glucose by glycogenolysis and gluconeogenesis. When following a carbohydrate-free ketogenic diet, plasma glucose is maintained somewhere between 80 and 100 milligrams per deciliter. This happens because of the effects of glucagon and epinephrine on the liver's glucose output. Under the influence of these two hormones, the liver's two pathways responsible for restoring blood glucose, namely glycogenolysis and gluconeogenesis, are both activated. By restoring blood glucose, the liver provides key tissues like the brain and red blood cells with the glucose they need as their major energy source. When following a low carbohydrate, high protein and high fat diet, a ketogenic diet, the liver will use excess amino acids from a high protein diet, specifically glucogenic amino acids, to synthesize glucose and maintain plasma glucose at a certain level. The liver cannot store amino acids and can only use their carbon skeletons to produce glucose through de novo synthesis. Fat in the diet cannot be used to make glucose because metabolism of fat produces acetyl-CoA, which cannot be converted to pyruvate. In summary, the protein-rich component of a keto diet will provide the amino acids, carbon skeletons needed for maintenance of blood glucose and restoring glycogen stores in both muscle and liver. Whereas the triacylglycerol enriched fat component of the keto diet will provide energy to several peripheral tissues through beta-oxidation of fatty acids. The latter process will provide energy to several key tissues, including the liver, skeletal muscle, heart, but not the brain. If you like this video, please subscribe. Thank you.